Hello students, let us discuss the types of covalent bond on the basis of overlapping of atomic orbitals. As we have already discussed, the s orbital which is spherical, non-directional, the p orbital that is dumbbell shape which is directional. So as we have discussed that there are three orbitals in the case of p subshell, that is when the lobe is on the z axis then it is called as pz. So this is pz. So we'll consider the three axes in this way. This is the z axis, this is one is the x and this one is y. So when the dumbbell is on the z axis then it is called as pz. And when the bundle is on the y-axis, if this lobe is on the y-axis, then it is called as py. So, but this should not be there, py. And if it is on the x-axis, then it is called as px. So, the s orbital that is a non-directional and the p orbital which is directional, that is px, py and pz. So when the atoms are approaching to each other, their atomic orbitals are overlapping. So let us discuss the two type of overlapping here. So the covalent bond may be classified into two type depending upon the type of overlapping here. First one is sigma bond and the second one is pi bond. Sigma is represented like this. This is sigma. And pi we can represent like this. So there are two type of covalent bond depending upon the overlapping, that is sigma and pi bond. So first let us discuss about sigma bond. Sigma bond, this is a type of covalent bond formed by the end-to-end or head-to-head overlapping of atomic orbital along the internucleus axis. So when we talk about the SS overlapping, so this is head-to-head overlapping. So this leads to the SS overlapping. So here there is a formation of sigma bond. So the overlapping of atomic orbital leads to the bonding, that is called as particularly when there is the end-to-end overlapping, that is called as Sigmum bond. When we take s orbital and p orbital, this is pz. So when they are overlapping, you can see it is a head-to-head overlapping. So this is called as sp overlapping. Similarly, p and p can overlap, that is pz and pz can overlap, and this overlapping along the internucleus axis. So this is also called as head-to-head overlapping, because the tip of this head-to-head overlapping is taking place, or we can say end-to-end overlapping is taking place. So this overlapping is also called as axial overlap. This is also called as axial overlap. So what we can define the sigma bond? It is a type of covalent bond which is formed by the head-to-head overlapping of orbitals along the internucleus axis. So as we have discussed the s orbital and p orbital, so particularly when the orbital, we are talking about the p orbital, when the lobe is on the z axis, that is called as pz. So in the case of s and pz, the side head-to-head overlapping is possible, because when they approaches each other, this part can overlap. Head-to-head overlapping is possible. But when we talk about the p orbitals, that is px, this is px and px. So here, because it is in this way, so here the head of this does not overlap, because there is no possibility to overlap, just like the case of pz and pz. So here there is only one possibility, that is they overlap, that is a sidewise overlapping. That is the one, that is px and px, they will overlap side by side, not head by head. Just in the case of here we have discussed the pz and pz are, that is overlapping, that is head to head overlapping. But in this case there is no possibility of head to head overlapping. In such case the overlapping is actually, that is sidewise overlapping. That is nothing but the called as, it results in the formation of bond, that is pi bond. Therefore we can say that in the formation of pi bond, the atomic orbitals overlap in such a way that their axes remain parallel to each other. Since here these are parallel, so head to head overlapping is not possible. Therefore the orbitals formed here, they will form a sidewise overlapping. They overlap sidewise. So it results in the formation of a bond that is called as a pi bond. So because of this type of overlapping, the two saucer type of charged clouds above and below the plane of participating atoms exist. That is shown here in this diagram. So this is about the pi bonding. That is in simple words we can say the bond which is formed due to the overlapping of atomic orbitals, that is sidewise overlapping of atomic orbitals, it results in the formation of pi bond. So when we talk about the strength of sigma bond and pi bond, basically the strength depends upon the extent of overlapping. In the case of sigma bond, there is greater extent of overlapping, therefore sigma bond is more stronger in compared to the pi bond. Because in the pi bond, the extent of overlapping is smaller. So we can say that sigma bond is more stronger than the pi. So here the overlapping of half-filled orbitals are taking place. That is overlapping result in the formation of bonding. So that is about sigma bond and pi bond. So it is important to differentiate between the sigma bond and pi bond. So first, the sigma bond, it is formed due to the end-to-end overlapping or head-to-head overlapping of orbitals, and the pi bond is formed due to the sidewise overlapping or lateral overlapping of orbitals. Here we have discussed the sigma bond, that is overlapping of SS, overlapping of SP and overlapping of PP. In the case of pi bond, the overlapping, that is sidewise overlapping, is only possible in PP orbitals, that is in PX which is parallel to each other and PY which is parallel to each other. So since here there is a greater extent of overlapping, so the sigma bond is more stronger, and in this case the extent of overlapping is lesser, therefore pi bond is weaker bond. So this is all about the sigma bond and pi bond, which is quite important topic. Always a question comes here, differentiate between sigma and pi bond.